or the point of building software is to produce something quickly that a business team can look at and understand and figure out if it's providing value to the organization.
I've worked with a few companies that think that continuous delivery is engineers do stuff and then QA people come in and verify said stuff and then it's finally ready to go out. And usually that, again, happens on a cycle. So there's this weird idea that the faster that these cycles become, the more continuous these deliveries become. And that's not really the case.
The business wanting to say, okay, we're not going to release this until it's done. Whatever that thing that needs to be done has parts that will interact with what other teams are working on. You know, they're building some API, internal API to use. If they can't release that until the whole feature's done, then it's going to slow up those other teams who are relying on that API.
All right, today we're going to talk continuous delivery. I have with me Jeremy Wood, Maharshi, same crew that we've been rolling with here recently. Say hey, guys.
Howdy.
How's it going?
Yeah, continuous delivery, fun thing to talk about because it is quite often misunderstood to be a certain set of tools as opposed to a methodology. And you know, in engineering software, we like to talk about our methodologies, right? Agile Manifesto and all that. And then we also like to talk about the tools that we use to implement those ideas. And so continuous delivery, just to level the playing field for everyone, this is something that's been around for a very long time. It really came into the spotlight with the book, I believe, by Jez Humble. Am I wrong on that? I think it's Jez Humble. Anyway, it's a great book, Continuous Delivery. I'll look it up as we're talking here. But the point of building software quickly, or the point of building software is to produce something quickly that a business team can look at and understand and figure out if it's providing value to the organization. There are a lot of ways to do this. Cranking things out sprint over sprint and deploying each individual sprint is a way to do this. I would argue that is not continuous delivery, although I have seen some people use that as the definition of continuous delivery. But really, it's more about creating value and getting software out there now as opposed to later, right? Forget the release schedule. We don't care about the release schedule because the release schedule is right now. So I want to throw it back to the crew. So Jeremy, Maharshi, let's start with Jeremy. Talk to me about your sort of, what have you seen people think continuous delivery is, but it in fact is not?
Yeah, like a big, long release cycle where we have software that needs to go through manual QA regression testing. We have like you said, a sprint at the end of the sprint maybe, where we say, okay, now we're going through this regression period. They'll do the regression testing, and then we'll hit some buttons in Jenkins to manually deploy this thing to a prod environment.
Right. It is Jez Humble, by the way, so I was not wrong, which makes me happy that I remembered that. What about you, Maharshi?
Kind of along the same lines. I've worked with a few companies that think that continuous delivery is engineers do stuff and then QA people come in and verify said stuff and then it's finally ready to go out. And usually that, again, happens on a cycle, so monthly, weekly, etc. Yeah. And there's this weird idea that upper management gets in their head that the faster that these cycles become, the more continuous these deliveries become. And that's not really the case. So, yeah.
Right. I think for me, the biggest challenge in doing continuous delivery correctly, and I think this is where a lot of the compromises and the nuance comes from folks doing air quote CD, but not really, is that it's very difficult to get an input into a software delivery machine that is a unit of work. Like if you think back to the Agile training that we all had, long time ago, late 2008 for me, there's this concept of every ticket is some form of unit of work, right? It's equal to X. And in modern Scrum terminology, we do planning poker, and that's a Fibonacci number, right? Because Fibonacci's fun and nerdy, and it makes us all feel cool. So at that point, that unit X has some amount of time associated with it takes for us to get it out. But oftentimes that is a breakdown of a larger ticket. Or like the engineering team receives from upon high this giant feature, and they have a tough time putting it into components that you can release into the ether. And that is a difficult problem to solve. There's no silver bullet for that, other than using things like feature flags and other sort of interesting engineering concepts where you can push things out without worrying about it aligning to the air quote business value. So there's this push-pull, right, that you see. The business team is like, well, why am I releasing this? It doesn't do anything. And the engineering team is like, well, we need to get it out, right? How have you guys seen that push-pull in your time?
Yeah, the business wanting to say, okay, we're not going to release this until it's done. But like that, whatever that thing that needs to be done has parts that will interact with what other teams are working on. And so like, they're building some internal API to use. And if they can't release that until the whole feature is done, then it's going to slow up those other teams who are relying on that API.
Right. And you get into this sort of octopus, right, of different dependencies where it's like, oh, well, I need that and I need that, and this team needs that and this team needs that. And so, again, the way to do this is to decouple all of those things and stop worrying about sort of the end-to-end creation of the entire gigantic epic, and instead just say, look, it's fine if we release this one thing. And I think the critical thing to doing that well is what? Testing, right? You have to make sure that you've built the appropriate tests that prove out BDD, whatever you want to, like however you want to create the specification that says that this particular feature is done, right? It works. But having those tests run in pipeline is an important piece of being able to go back to the business and say, yeah, we shipped this, but we put a feature flag on it. It's, all the tests pass. So we're fairly confident that when the UI team finishes their work, we just flip the feature flag on a deployment and they hook up to it and everything's seamless and it just works. In a perfect world, right? This is very hard to actually pull off. What about you, Maharshi? Have you seen this sort of push-pull work?
Yeah, it does help you become more fearless whenever you're committing code. When you have feature flags, especially when management is kind of hounding you a little bit on, hey, this needs to get done by this deadline. You don't need to stress about, that other team hasn't gotten their work done. If we push this now, it's going to break theirs, it's going to break ours. You just have the feature flag, push your code, and you're good to go. And you can show that to management specifically as, hey, I have completed this work. We have met the deadline. And here is the proof that when it's turned on, it will work. So, yeah.
I think that's critical because, again, and this is just speaking to my business folks, like when something is done, just because it doesn't show up on a screen doesn't mean that it's not, right? And that's the big thing you're hitting on, Maharshi, is that a feature is complete sometimes when the engineering team says it's complete. And that's something we don't really like as business because it's harder for us to verify that, which is totally fair, by the way. And that's why I encourage my business folks to kind of learn what tests are. Like learn that it's not that a regression test suite, other than probably what you've heard, on the street. I've heard 15 overloaded definitions of regression test in my life in the decade plus I've been building software. And honestly, for us, for the way we define that, it is a good, high quality set of unit tests that cross system boundaries as necessary to prove out that a particular set of code does the thing that we think it should do. Which means to the business person, when that goes out, you should have confidence. It doesn't mean it's perfect, right? I could have fat fingered a thing or two, but it does mean that it works the way that we expect it to based on the inputs and outputs we got from that ticket set.
One thing to note is feature flagging, like you said, isn't a silver bullet because there are no silver bullets here.
Right.
And it's something that it is, to get continuous delivery, it's kind of like a fact of life, but doing it well is hard. These feature flags one client we were working with had a trust issue with the feature flags that we were using, because it's meaning that like code is going out even if it's disabled, right? But
Yeah.
there still needs to be testing, one, to ensure that when the feature flag is off, that code is not live, and two, when the feature flag is on, that it works as expected.
Right. Yeah. I want to dig into feature flagging too. I mean, this entire episode may just be about that, to be frank, because it kind of is what you do. Like, there are other ways to do continuous delivery, like get your feature complete. But we all know that's very difficult to do in a business context. Maybe not for Amazon or other companies that can kind of break this into really tiny slivers. But to me, there are a bunch of ways to do feature flagging wrong. And I'll give a story of how I saw this at one particular client a long time ago, whose logo is orange and sells hammers. I was working on a giant Java project. It was like 9 million lines of Java code, I kid you not, with 10,000 line classes. And I was very young in my consulting career, and I suppose very naive in that I thought everybody wanted to write good code. And unfortunately, some people, when put under duress, don't do that. And again, it's their fault, but it's not really, right? But when working on this project, I discovered a database table called config. And you can see where this is going. Opened up that table. It had column 1, column 2, column 3, and they were all called like param 1, param 2. Or first column was name, param 1, param 2, param 3, param 4, all not to param 12, I think. They could have at least gone to 16 to give it a power 2. Come on, guys. And in this entire, basically a giant null matrix. It was a matrix of nulls, except for occasionally you'd see like a string or an int or a number. And by the way, all the columns were varchars. They were not actual proper numbers or, efficiently stored data types in a database. They were all varchars. And this table, when I asked the lead engineer on the project, he just looked at me and shook his head. And I was like, well, okay, what does this table do? And he proceeded to tell me, well, that's how we turn things on and off in this particular application. And I was like, oh, okay. First off, I see a lot of things wrong with this. Number one, you have to do a parse on everything that comes out of this table. Number two, what happens if the database goes down? How does your application manage it? And this goes into like the 12-factor app idea of like every feature flag should have a reasonable default, right? In 12-factor app, it's even more intense than that, but everything should have a reasonable default. And the question, again, no one can answer these questions. And you open up the code and you see like this one way, we're handling it this one way with that default. In this particular section, we're handling it this way with that default. It just becomes such an incredible cognitive load that you can't actually figure out how the application is configured. So please, for the love of God, do not use databases for your feature flags. You can do it right, and I've seen it done right, where again, column true false, right? To me, a feature flag is it on or is it not? It's a true false Boolean. It's not 15 flipping params on weirdo tables that I have to parse, and when it breaks, my whole application dies. Secondarily, I would argue, and then I'll let you guys talk about this and tell me your thoughts. I would argue you probably should be wary of using external APIs for feature flags unless you've engineered those defaults properly. Like LaunchDarkly. Again, LaunchDarkly is a great product. Like one of our clients uses it. It's fantastic. It does auditing of the modifications to your feature flags. It lets the business change feature flags, which maybe, think about that. Maybe you should do that. Maybe you should not. Really depends. But this allows you to at least control and audit who modified those feature flags other than some random table in database or a file that you push up. There are other ways to do this. I want you guys to jump in. That's my funny story, but what are your thoughts? How are some ways that you've seen feature flagging done correctly, incorrectly, and what are your thoughts and commentary on that?
So you brought up how feature flags are supposed to be kind of true or false, right? And that's the way that I view real feature flags to be. If my feature is working, then I'll just I flip on a switch and it's true and I'm set. My feature flag ideally shouldn't be sending back strings or integers or arrays. And unfortunately, we had a client that was doing that. Not to say that the code was bad, but what if launch darkly goes down? Then this feature flag is only ever returning false. Or it's returning an alternate string, or it's returning nulls, in fact. And I don't really like to see feature flags work as like if statements. I want them to be I don't want them to be conditional. They're either true or false. That's what I was getting at.
Yeah, for sure.
So yeah.
Yeah, I've seen.
What about you, Jeremy? What do you think?
I've seen it done a bunch of different ways, and I have a lot of thoughts about the way that it should be done. And honestly, I don't know if I know what the best way is. It's just like, this is a way that seems good, and you say it should be true or false, and just don't tell people who use services like Launch Darkly or Split.io for tell them that, because I mean, like, Split is more than just feature flags. They have experiments or something, so they can do analytics based stuff, and I think there's definitely value in that, where you have some exploratory feature that you want to turn on for some subset of users, and that is something that the business would need to be in control of, so that they can manage that, because that's not something that programmers are going to want to do. But then there's situations like where you're using trunk-based development and you need to deploy code that is turned off, and I think that like that really shouldn't be using that kind of service for whether or not that's turned on, because either you've got this code complete, in which case it shouldn't be behind I should back up. There's we can bake feature flags into the code, and have those values configured at a code level, like say if you're building a Spring app, put them in your app config to turn this off, and it should be off in higher environments until the feature is done. And then once it's done, if it's something that business wants to be able to control the deployment of, you move that out of there and into whatever service or whatever you're using for business control of features. But like if the code is not working, then it shouldn't be up to business to turn this on. It should be what the engineers should be deciding, that like this is off because it is not working.
Right. Yeah. I to jump in there, I think first I agree with you that not all feature flags are true false, but I would argue that the difficulty is understanding the Venn diagram between configuration and a feature flag. So for me, and you use trunk-based development, which is a fantastic example, and I really like trunk-based. And trunk-based forces you to think about continuous delivery as a way of life, because the people behind you are like, get your thing done. I got my thing done, and it needs to go out. So let's get this done. And it does make for a more difficult orchestration across the teams, but it provides the appropriate push-pull when you're trying to get something out the door. But given that a random feature that needs to be air quote flagged, the follow-up for me is to think through, okay, is this an evergreen feature that's forever, ever going to be on? Like, for example, a new modification to a user API, right? Do I want my business to turn that off? Absolutely not, right? You're going to break the crap out of everything. Please don't, no. As opposed to that, some random exploratory experimental UI feature or a different color scheme or things like that, that makes perfect sense to say, hey, business, you can now control for 10% of our users, we're going to run this particular UI change, and for the rest of them, they get the old stuff, and you can use that to kind of understand if the modifications you're making are something that people enjoy. That I completely agree with, giving the business the appropriate access to. And then finally, when you have a feature or an evergreen API change or something like that, I am a huge proponent of delete the feature flag eventually. Get rid of it. Why is it there, right? It's dead code. The compiler will literally get rid of it. If it's like an if true, it'll just, no, we don't ever want that. We're going to remove that. So it makes sense to reduce the cognitive dissonance of having X different features and be like, well, is that one on? Is that supposed to be on? Is that supposed? I don't know. So from the engineering team perspective, I see two sets of feature flags. One is the business being able to turn some knobs and pull some levers, and the other is the engineering team saying we're doing this for the sake of getting features out, and eventually these features flags will be deleted from the code base.
That can be a hard sell for business.
I know.
And it shouldn't be. Like,
Yeah.
this features flag got to be removed once this thing is not ever going to be turned off, you know? And,
right.
like, the best way I've seen that done is, like, create those tickets up front when you create the feature. And make sure that those tickets are, like, included in your sprint or on your to-do list, whatever. Make sure that they're priority along with the feature.
Yeah. For sure. And I think that's the biggest challenge is making sure that you have that follow-up. Because, again, not just with writing tests or anything that requires discipline from an engineering perspective, people typically are just like, we'll do it later. And then it never gets done, right? With a ball of spaghetti mess. I want to talk a little bit about the cognitive dissonance of that, too. So I think that the more feature flags you add, and if you're not careful and you just think of it as a one-to-one, where like one ticket, one feature flag, one push, that one-to-one will become combinatorially more ridiculous as you add more features. So it actually is very important that you clean the campground when you're done, or you think more strategically about your feature flags instead of just shoving them in as a way to get my code out. You need to actually engineer the thought process around how this particular feature flag enables this business value.
I feel like we should maybe circle back to continuous delivery.
Yeah, let's do that.
I mean, feature flags are definitely a big part of that because, let's face it, like, trunk-based development is kind of the best way to get continuous delivery. And with trunk-based development, you got to have feature flags or you're not really doing it.
For sure. And I that is one of the more difficult sells for whatever reason in an engineering organization. And I'm talking about the developers on the team. I'm not talking about business, because business doesn't care what your Git looks like. But how you convince a developer that trunk-based is a good thing. Like, I had this problem with one of our customers when I came in, and this was back 4 or 5 years ago when I was still doing real work. I had a deep conversation with the team about, hey, I think they're using some bastardized, god-awful version of Gitflow, which is terrible. I'm sure. I hope Gitflow. I hope whoever invented that feels bad. No, sorry, because it's great for certain things when you're releasing code on CD-ROM, but it's just very, very difficult for people to actually produce value in without a release manager. But anyway, maybe we'll cut that part. But that was a fun diatribe. So trunk-based development is difficult because people just they can't get their brain wrapped around that I can be a bottleneck, right? So if I'm working on a feature, I'm trying to get something out, and I'm doing this merge, it has to work. And you can have multiple people trying to get into mainline at the same time, but that's okay. That's the entire point of having unit tests and having some form of pipeline that runs those tests to ensure that the integration of feature A and feature B do not, in fact, bring down the entire API.
Yeah, and that's really we're really talking about continuous integration here, because
they're coupled, right? CIC.
Sure. But the thing is that trunk-based development can be difficult for the engineers to wrap their mind around, but it's harder to wrap your mind around merging in these giant feature branches that are months old and have, you're talking about integration. That's difficult.
Yeah.
And like, if you think it's difficult to merge in like a small short-lived branch, then yeah, you just need more automation around like testing and.
Well, you don't need more automation. You need more bodies, because you, as I said earlier, you have to have a release manager that does all this stuff. Like, even back when I was at Danger, we were using Perforce. We had a release manager, and this person would cherry pick commits all over the place. I have no clue how they kept it all straight, right? Because I'm sure there were stuff that got left behind. There were changes and features that were not merged in that should have been merged in, because you're relying on this one human to understand sort of this combinatorial explosion of X branches, all with certain commits that you want to pull in for a target release. And again, if you're a really good, amazing release manager, you can do this, and you can do this well. But I would argue just push everything at once, right? Short-lived feature branches, and again, there's a difficult line to walk there too, right? Because what's the definition of short-lived in the trunk-based development world? Well, it's definitely not a day. I've seen branches take longer than that, depending on the feature. Obviously, a day is probably the most ideal situation, and it's definitely not a month because that's way too much work to get merged in, and maybe your ticket's too big.
I think it's harder. Oh, go
No,
ahead.
you go ahead.
I was going to say, I think it's harder to convince a team to use trunk-based development when they don't really interact with anybody outside themselves.
Yeah.
So if they get a feature, it's just for their team. They don't need to wait on like a DBA or some other team, because then they're not having to worry about where the bottleneck. So yeah,
Right.
I think one other side of this is like what is the right length of time really depends on how many engineers you have interacting with that code and like how much overlap there is. Because like if there's no merge conflicts, then if you got one developer, that's not it doesn't matter. There's no integration issues, right? Yeah, you can just push straight to main. Exactly.
To main, yeah.
But if you have a bunch of developers, if it's a large code base and each person is working on disparate sections of the code, then you also don't have much of a problem with the branches lasting longer. So
Right.
it's more of like, do the
Something-
features need to integrate with each other?
Yeah.
That's where you need it to be shorter lived.
Something I don't see people do that I think they should do more often, and again, if everyone's doing this, I'm not seeing it in my customers, is to pull another person's branch and merge that in with yours. So if Team A is working on something and Team B is working on something and Team B finishes up early and there's some pieces of something in there that I need to interact with, then the obvious choice is to pull from branch B, merge into branch A, and do some testing before you commit up your branch A, right? And again, in theory, the right set of tests should solve that for you, but I understand that's theory crafting and not like life. But at the minimum, pull someone else's branch and check it. I used to do this all the time when I worked at several customers and also in my product lifetime, is I would pull people's branches, look at it, understand it, do some merging into my own branch, see if it worked. And if it did, I'm like, yeah, I feel good about this. Let's get this in. Cool. So trunk-based is a big piece, I think, of doing continuous delivery, right? You can obviously do continuous delivery any way you want because automation in 2024 is incredibly complicated. You can do some pretty crazy things, like GitHub Actions are fantastic. They have a lot of really cool things you can do. You can do ephemeral environments if you'd like through Actions and sort of some other CI/CD tooling. But I don't think that's sort of the key to doing CD correctly is just having the right tools. But they certainly help. What are some other tools that you guys have used that you think help accelerate continuous delivery?
GitHub Actions is definitely a big one. Being able to have automation running on pull requests, so that that most likely when this goes in, the tests are going to pass. That's a big part of it.
Yeah, I've honestly only mainly used GitHub Actions for CD. I used Azure DevOps way long ago, but I don't even remember what really happened there.
I don't think they know either.
No, I think we had the same processes in place, like tests on PRs. But I think the coolest thing that I've seen done with GitHub Actions is it'll do a pre-commit to the main branch, run the test there, and if there's an issue, it'll tell you in the PR, but it'll also ping you on, hey, what you might be able to change to fix this. And I thought that was cool.
Yeah, that's some of the new AI stuff they're doing, which is really, really neat. I think that's sort of next level. As far as I hated on AZDO there for a minute, but I mean, they were ahead of the curve for a while on developing really good continuous delivery workflows. So they get a lot of credit for that. But I mean, the oldest is, I was doing CD on Subversion. I remember the ThoughtWorks deck that I stole from a friend who worked there. that talked about continuous delivery and used subversion like in the slides, which was hilarious because subversion's terrible at branching, which is why everyone used trunk based on subversion anyway. If you branched in subversion, it'd take you 19 hours to get your copy of source code. It wasn't until Git came along and introduced this pointer based approach to how commits work that we were able to have lightweight and free branches, which was a good thing, but we overcorrected by branching the hell out of everything and creating this spaghetti monster of branches as opposed to sort of the heavyweight, difficult to work with branches of SVN world. But I think that for me, a big tool that has helped continuous delivery is Docker, which sounds weird, but containerization has solved so many problems for us. It has created, it has all but solved dev prod parity if you know what you're doing and you know how to do Docker right. It solves dev prod parity for you. It also allows you to produce an asset and get it into an environment very quickly for testing. And that's a real environment, which has been a problem, right, in our past as the development community, right? It takes a lot of work to spin up new machines. Well, in Docker, I just shoot a container into an ECS cluster or a Kubernetes cluster, and it's up, and I can do what I want with it. Those are very, very powerful things that allow me to deliver value into the hands of my customer that's real and that can be played with almost immediately.
Mm-hmm.
Yeah. You mentioned at the beginning, I think, that like CI/CD or CD is not it's not tools. It's like a methodology. It's like a process. And that's just like case in point. Before I worked at 7-Factor, I think maybe the only tooling exposure I had was Jenkins. And you can hate on Jenkins a lot. That's easy. Configuring it is a nightmare sometimes. And it's what we call click ops, unless you're using their pipelines. But even then, configuring Jenkins itself is a lot of clicking. And like my point though is that we call that a CI/CD tool, but if you're not continuously delivering, deploying, integrating with it, then it's not really that. It's not CI/CD.
Right.
It's just a tool that helps you do those things, but you still have to work the process to get it to be continuous, to get the benefits of continuous delivery.
Yep.
Yeah, I've hated on Jenkins my whole career, but it actually isn't a terrible product. Go ahead, Marshy.
Yeah, I've seen a lot of assumptions before 7-Factor, when I was at a transport company. A lot of the assumption around what tools you used was, can I use these same things in prod and reflect the exact workings of it? The answer was usually no, but you would get close enough that, oh yeah, I would be able to push this into dev using the tools that I have and be okay with the results.
Yeah.
And I didn't know what Docker was back then. I mean, I used it, but I didn't know what it did. I knew how to run my code on Docker, and the only thing that I was ever told was, you can run it on IntelliJ and it'll work, but if it doesn't work on Docker, it is bad. And it didn't. It took me until way into 7-Factor to realize what that really meant.
Yeah.
So yeah.
Yeah, and that dev prod parity is critical to just delivering good software, which is an entirely different conversation. But I mean, and to kind of bring it home, like continuous delivery is something that a lot of people misunderstand because they think that it is a set of tools, like we just discussed. They think it's trunk-based development, or they think it's just short-lived feature branches. Like you ask 10 people in the engineering community what is continuous delivery, you're going to get 10 different answers when you ask them, when you dig into it. Like initially they'd be like, oh, it's pushing production every day. Yeah, but how, right? That's the big question. How do you do that? And to me, it's again sort of a twofold problem to solve. There's the engineering side of continuous delivery, which is in fact tools. It is figuring out the right methodologies, how we develop and deliver software, how do we branch our Git, how do we automate that? Like that's all a set of problems that need to be solved, but they're different flavors, like grape versus cherry. They both taste good, but one's grape and one's cherry. One's Jenkins. Again, Brian Regan joke there for anybody who's a boomer. But that needs to be coupled with a business understanding that, hey, business, we're going to push stuff, and you need to be comfortable with that. I see this dichotomy on the business side of they're like, oh, go, get it done, work the weekend, get it done. And then when we're like, oh, hey, we can push this code that doesn't work, they're like, oh, hold on. No. What are you doing? Why are you pushing that? It's like, because I can. I promise it won't break. Now, there's some other ideas around security and hacking, and that is a true concern, right? To not make light of that concern, because it can be a big deal where if I push something and someone figures out how to fiddle with my feature flags and turns something on, you're in trouble. This is why feature flagging on the front end is probably a bad idea, because anybody with 20 seconds and who knows JavaScript can hack the crap out of your stuff. Don't feature flag front ends. At least I haven't figured out how to do that correctly. I'm sure someone has. But this dichotomy of, get it out yet don't is a thing that you have to manage, and you have to talk with your leadership and talk with your business and say, look, we don't want to scare you, but trust us. It'll go out and it'll be fine. And we're just going to push this code because we want credit for it, and we're flipping sprint points. I want credit for it so that I get my gold star at the end of my sprint, and I get my, I hit my sprint commit. So I get a pizza party or something. I don't know. But that's the hard part of continuous delivery. It's not that there's this insurmountable technical problem to solve. It's an organizational problem alongside some buy-in and the right tools and the right automation team to get that out for you.
Yeah.
So we've had fun. We've talked about a lot of fun things. Again, Jeremy Maharshi, always a pleasure, my friends. Thank you for your time. Hopefully someone learned something from this. Check us out. We have a bunch of other YouTube videos where we kind of have fun and ramble about some stuff. And hope everyone has a great day. And we'll talk to you all on the next one.